Hello and welcome to today's daily Leetcode challenge. Today we'll be solving question 1155, number of dice rolls with a target sum. Let's get right into the description. This is a medium level question. You have n dice and each die has k faces, numbered from 1 to k. So our normal 6-sided die would have been with k equaling 6. Given three integers, n, k, and target, n being the number of dice, k being the sides, the number of sides, target being the sum, I guess, that we're trying to reach, return the number of possible ways out of the k to the n total ways to roll the dice. So the sum of the face up number equals target. Since the answer may be too large, return it modulo 10 to the 9th plus 7. All right, so this is a pretty complex, I would say, description. Let's get into some of the examples. We have n equaling 1, meaning that we have one die, and it has 6 sides. So that's our normal sort of like cube with 6 sides. 1, 2, 3. Return the number, the target 3, and the output is simply 1. That's pretty clear. Example 2, we have 2 dice now, and k equaling 6, so the number of sides is 6, target being 7. Well, I know that there's 1, 6, right? There's a way to get 1, 6 by having the first die equaling 1, the other one 6, and then there's also a 6, 1, so the first equaling 6 and the second equaling 1. All right, well, I guess this is not what they want. They also have the 2, 5, 3, 4, 4, 3, and 2, 1. So it's not just that we can. So besides the reordering of the dice, they also have the other ways to get 7, which makes sense. So I would have thought that maybe this would be equaling 3, 1, 6, 2, 5, and 3, 4, but there's actually 6 ways because the number that the die shows up actually matters as well. So 1, 6 is not the same as 6, 1. All right, well, let's think about this for a bit. The tendency to go for a combinatorial solution where we have, let's see, for n number of die and that has k sides, there is k to the n number of combinations of those die, right? So that's a pretty significant number. Out of those, there are some specific number of combinations that we want. And that is actually what's interesting to us, right? So this is not like this is not a ratio. So the combinatorial solution probably exists, but let's see if there's another way to think about this. What if we were to claim that to get a specific target, let's say the target equaling 5, at an n of 4, so 4 dice, and k equaling 6, our standard 6-sided die. What if I was to say that to get the target 5, I could ask a different question. I could ask, what is the number of ways that I can get target minus 1, then target minus 2, target minus 3, and so on until I reach my 6. Target minus 6. But instead of asking that question with 4 dice, I'm going to be asking it with 3. So the same question that I've defined here, but now for each one of these, the question is target minus 1 with k still being let's see, k still being equal to 6, but n equaling 3. And same thing, k equals 6, n equaling 3. The sum of all of these guys could give us this number here, the requested number of ways to get that target sum. Why does this make sense? Well, if we have a 6-sided die and we want a target 5, then a way to get that target 5 with 4 dice would include the number of ways to get the target 4 with 3 number of dice, because when we have the target 4 with 3 number of dice, plus that one time that the die rolls a 1, right? So when a 1 rolls and we have 3 dice, when we have 3 dice and a target of 4, that's going to equal some amount. That amount, when the 4th die is rolled and gets a 1, that amount is going to contribute to the total sum of getting the target 5 with 4 number of dice and a 6-sided die. Okay, so I think we have some sort of relation defined. Let's think about how we're going to implement this. Well, if I'm using up or modifying the number of die that I need to have and modifying the target, that gives us 2 dimensions. I could define that as a 2D array with maybe the rows indicating how many die we have and the target and the column number indicating the target that we currently have. And given that I have this recursive definition for how to get my value, I can build up the array from start. From start being that when I have a target of 0 and 0 dice, that I can that I know that would take me, that there's only one way to do that. Okay, let's maybe think about visually what this would mean. I have a 2D array with n representing the number of die that I have, and I'm going to initialize it with just a bunch of the first index, the target, by the way. On the x-axis we have the target, on the y-axis we have the number of die. My initial, why isn't this working? My initial statement is that with 0 die and a target of 0, there's only one way to get this. When I have 1 die now, what is the number of ways to get the target 0, 1, 2, 1? Well, there's 0 way to get this, but there is 1 way to get a target of 1. That is just by rolling 1. So what you can see here is that I'm actually saying the question is that I'm asking is, given that I need to find this number here, n equaling 1, target equaling 1, the contributing factor to that is going to be how many ways can I get the target 0 with 0 number of die. And that's going to be here. So this plus, well, so far just this is going to be giving us 1. What's our next question? Next question is how many different ways can I get 2 with just 1 die? That's also just 1. And here, there's a bit of a difference from the previous calculation. Here, I'm asking 2 questions. Not only how can I get the target of 1 given 0 dice, but also still, because my die is at least 3-sided, how many different ways can I get 0 with 0 die? So you can see that I'm adding these 2 to get this value. Same goes for 3. How many different ways can I get the target 3 with 1 die? Just 1. Okay. Let's calculate for 2. How many different ways can I get the value 0 with 2 dice? 0. How many different ways can I get the value 1 with 2 dice? Also 0. Now, how many different ways can I get 2, the value 2, the sum 2, with 2 die? Just 1. And again, I'm using this, the sum of these. How many different ways can I get the value 3 with 2 die? Well, I know just from my knowledge of die that answer is 2, because I can have a 1, 2 or a 2, 1. But if I was to look at this graph and calculate how to do it with that, the questions I would be asking with 1 die, how many different ways can I get the target 2? How many different ways can I get the target 1? And how many different ways can I get the target 0? Now, again, why am I asking those questions? And these are all being contributors to the total sum, to the total number of ways that I can get this current value. Why am I asking this question? If I have 1 less die than I currently have, which is from 2 is just 1 up, 1 row up, how many, the die itself has 3 faces currently. This is a simplified version, right? And so if I was to look back and see which contributing situations get me this number, it would be 1 less die, but also a value on that face less. So it's just going to be the target that I'm trying to find now minus 1 face of the die, which gives us the face here, and then another one, and then another one. And so I can see now that it would be 2. So I think my sort of relation is now visually described, as well as hopefully vocally. Let's get to the description. Let's get to the implementation. So I probably need some mod here. 10 to the power of 9 plus 7. That's just to mod our result value. I need the DP array of, now what did we have here? We had number of columns target plus 1 because we're 0 indexing, and the number of rows just equaling n plus 1. So 0 of 0 times target plus 1 for in range n plus 1. Cool. I also am initializing my first base case to 1. because I know that it takes, with 0 die, there's only one way to get the sum 0, and everything else is going to be 0. Now I'm simulating going through my rows and adding up all the values here, right? Let's see, I'm going to be saying for I in range from 1 to, what is this going to be? From 1, well, I'm going to be iterating from I to n, right? Then for j in range, let's see, I need to start at I because this diagonal here defines we're eliminating the need to calculate how many different ways to get the target that is less than possible. So from I, but here I also need to figure out how far right am I going. And to figure out how far right am I going, oh, and this is actually +1. I have the target. I have the potential for a target, but also, what is the max possible value here? Is it potentially just n times I times k? I times k being the total max that I can even get with the number of die that I have. So actually it's just going to be I times k and target +1, just because we are 0 indexed rather than, or 1 indexed rather than 0 indexed. Okay, and now we need to calculate the sum. dp of I and j should be just equal to the sum of the subarray of the row below. Now let's see how this would work. The sum of the subarray of the row below, dp of I minus 1. Here, however, we need to think about, is it just going to be, see, this is a bit complex because I know that there's a left barrier and a right barrier. The barrier here is just going to be j minus 1. That's the end. But what is going to be the starting point? Would this just be the max of j minus, no, would this just be j minus target? J minus, okay, wait, hold on. Before doing this, let me get a bit simpler. For temp and range, I'm gonna start off from 1 to a min of j k dp I j is equal to dp of I j plus dp of I minus 1, the row above, and j minus temp. Quickly go into what that means in a second, but we also need to mod this and return dp of n and target. So this quickly works, and then if it does, do I need to say +1 here? Let me quickly go into what I'm doing here. This temp value is actually me going back one by one from the row above, I minus 1, to j minus temp going from 1, so going to the left 1, up to the minimum of j or k. Now what is j or k? K is the number of sides a die has. So for example, here I was assuming that the die has 3 sides, but what if a die only has 2 sides? In that case, I wouldn't be considering this 0 here at all, because the number of ways that I can, the number of potential contributors to the current target is only 2 with the n minus 1 die. Why? Well, because to get this 2, now there's only two previous sums that would allow me to get this 2. That would be the target minus one of the faces, and then the target minus the second face. Target minus 1, target minus 2, the different kinds of faces. So I'm getting the minimum of these 2 additionally. Well, k makes sense. Why j? J is just so I don't go step over bound. There is a chance that here I have a face of 30 and I would be stepping over my bound. So given that, I actually want to simplify this. I want to say that dp ij is equal to the sum, and hopefully this works, sum of the dp I minus 1, and with a subarray of maximum of either 0 or j minus temp, and the lower bound just being j minus 1. And I also want to mod this by my mod. Let's see if this works. Hopefully it does. Temp is not defined. Oops. J minus, what did I say? Minus 1. Nope. J minus K. Okay, I'm getting some issues here. First of all, it's going to be just J because, cool, awesome. That worked. So just a simplification. Let's see if this actually works. Sweet. Remove this. And we should be set. This should be a pretty good solution, and we're doing about 98% better than the rest. Let's see if I can submit it without that comment. And everything else looks pretty good. Right. Well, a bit slower, but still 98th percentile. Awesome. I'm thinking that the solutions here are roughly the same. If not, I honestly think that my solution here is extremely thorough and intuitive, especially that I drew it all out, and it's actually not that much to code. Yeah, you know what? I don't want to bother reading all of the other solutions. They seem to be very non-explicit, whereas this clearly shows you the relationship between the current target that you're trying to reach and the targets that would have helped you reach that target if you were to have one less die than you currently have. So please use this. This is very thorough and easy to read, in my opinion. All right, well, thanks for watching, and I will see you later.